Hey, let's take a close look at not only how to take the derivative using the power rule, something you'll no doubt be doing a lot in your calculus class, but I'll also show you how to put the calculus gears in reverse and find what's called the antiderivative of simple polynomial functions. I think a great case could be made that learning the derivative and the antiderivative all at the same time will serve you well throughout the course that you're in because, frankly, you'll be using both of these essential skills an absolute ton. Okay, so let's get started. Here's a function f of x equals x to the third, and they're going to ask us to take the derivative. So we're going to find f prime here. That's called finding the derivative of the function. So the way we start is we start with the function itself, x to the third, and we take the exponent and we throw it out front as a coefficient. So it becomes 3x to the third, but wait, we're not going to leave the exponent as a 3. What we need to do is we need to add -1 or reduce it by 1, subtract 1. However, you need to think about that, and we're going to have a new exponent that is a 2. So our derivative ends up being 3x squared, and we're done. We just found f prime. So we started with the original function f, we took the derivative, and we got 3x squared. So let's now put the vehicle in reverse and see if we can figure out what the original function was if I give you g prime. So I'm giving you g prime here. It's 8x to the third, and we're going to try to work up the board and try to figure out what the original function was, g of x. Now this is called finding the antiderivative when you work so-called up the board and figure out what the original function was. So there is a procedure for that, and it's very similar to the power rule. We're just going to do it all backwards. We're going to do it all backwards. So the first thing we're going to do is we'll start with our x to the third. And remember on the left side of the board how we subtracted 1 at the end? Well, we need to add 1 to the exponent on the right side. So we end up getting a new exponent of 4. So it becomes x to the fourth. Now that we have x to the fourth, we can look at that coefficient 8. Now it's not going to stay 8 because if you remember on the left side, we multiplied by 3. On the right side, when we're doing the antiderivative, we're going to divide by the new exponent. So our coefficient is 8. It's going to become 8 divided by 4, which of course is 2. You've just taken your first antiderivative. So the antiderivative of 8x to the third is 2x to the fourth. But wait, there's a little thing that we've forgotten about because we don't know. There might have been a constant at the end of this original function because the derivative of a constant is just 0. So there may have been a number there. Maybe it was 10. Maybe it was -20. Maybe it was plus 0. We don't know. So what we do is we just put a generic plus c at the very end, and that is the antiderivative of 8x to the third. All right, so now we're ready to take the derivative of a polynomial that has multiple terms. And all we do is we use the power rule on each term separately. So we're going to be finding the derivative. We'll find f prime when we're done. So on that first term, 5x to the third, what we do is we throw that exponent out front. Now we have a 5 there already, so we have to multiply 5 times 3. We get 15. And then we reduce the exponent by 1, which means we've got x squared. Now on the second term, we do the same thing. We throw that 2 out front. 2 times 3 is 6. Reduce the exponent by 1, we get 6x. And then on the third term, we've got -10x. So the derivative of that would just be the constant -10, and the derivative of +5 is just 0, so we're done. That is the derivative of that original function f. Now that wasn't so bad, right? The power rule is really quite simple. Once you get good at it, it's very straightforward and you can hit it out of the park. Now let's look at an antiderivative. All right, so I wanted to mix things up and give you a little bit of different notation. This is one way that you might see on your calculus test how your teacher or the AP exam may format things. So given capital F prime of x is little f, what does that mean? That means the derivative of capital F is little f. Well, that's kind of confusing, but okay, right? So I will give you little f of x, there it is, the polynomial function, and I might ask you to find capital F. Now what on earth does that mean again? Remember, the derivative of capital F is little f. So we're working up the board here and trying to figure out what the original function must have been to give the derivative little f. And that is what we call the antiderivative. So we'll be finding the antiderivative of this polynomial function. So let's go through our process. We start with our x to the third, and remember, we add 1 to the exponent. So now we have x to the fourth. And then we take that exponent, 4, and we divide by the new number. So we take the original coefficient 4, and we divide by the new exponent, and we get 4/4, which of course is 1, which we don't even need to have there. So let's move on to the second term now. So 6x squared. Now remember the procedure? We add 1 to the exponent, so we get x to the third, and then we divide by the new number. So 6 divided by 3 is 2. You see how easy that is? Power rule in reverse. The next term, we've got 8x to the first power. So we add 1 to the exponent, that's x squared, and then divide by the new number. 8 divided by 2 is 4. All right, and then the final term is a constant, but remember we're doing the antiderivative. So the antiderivative would be negative 2x. Now don't forget there might be a constant at the end, so you have to add the plus c at the very end of the question, and you found your answer. All right, you just found an antiderivative using the slightly confusing notation of capitals and lowercase f's, but trust me, you're going to see this on your test, so hopefully you could wrap your head around this. I really hope this video was helpful for you, so be sure to click that like button and check out some of my other calculus videos. All right, until next time.